So we have a couple of things to finish up today in our second unit of the semester. Depending on how you look at it, it's unit 2 or unit 7. Some I think of it as all the units from the beginning of the fall semester. Either way, we're finishing up our circles today. There's some things that we learned last semester that I just want to review. And that looks like a circle. My circle has a radius of 8 inches and an angle here of 60 degrees. How do I find the length of that arc? I'm going to label it points A and B. Arc. Now I know that it's a 60-degree arc because it's a 60-degree central angle. So we know that we can evaluate an arc based on the degrees of its center. But I want to know the length. What is AB? Not in degrees, but in inches. What's our first step? Do you guys remember? Find the circumference, right? Circumference of that whole circle is pi times diameter. Pi times 16 inches, or 50.24 inches of circumference. How do I get from the circumference to the arc length? What do I have to do to my 50.24 inches? And the central angle is 60 degrees, which means that arc is 60 degrees of the circle. How many degrees are in the full circle? So it is 60 out of 360 for the whole circle. I take my 50.24 times 60 divided by 360. That tells me that arc is 8.37 inches. I call the center of my circle O. I want to know the area of sector AOB. I start out very similar, almost exactly like my arc length. Only I'm going to find the area of the whole circle. Area of the whole circle is pi times the radius squared. So pi times 8 squared, which gives us about 200.96 square inches. Find my sector area. Take that area of the whole circle and I multiply it by ratio, because it's still 60 degrees out of the whole 360 degrees circle. So what does that end up being? 33.48, I believe, square inches. I'll double check that because it is late. It is 33.49. I'm going to touch out on my arrow. Now, the last thing that we looked at last semester something called a segment. Look like that. The area of segment. Remember, a segment is just the area between a chord and the outer edge of the circle. And to do it, first find the area of the sector. Sector AOB, already found, has an area of 33.49 square inches. Our second step is to find the area of triangle AOB. Now, we know that this length over here is 8 inches because it's another radius of the circle. Every radius of the circle has to be the same. So if one of them is 8 inches, they're all 8 inches. Definition of the radius. This is 60 degrees across here. What does that tell us about this length here? Also 8 inches, yes. Because if these are equal, it's an isosceles triangle, which means these two angles are equal. Subtract from 180, 180 minus the 60 is 120. We split that, those angles have to be 60. In other words, it has to be an equilateral triangle, so they're all 8 inches. So that means our perimeter, 8 inches plus 8 inches plus 8 inches, 24 inches. Our semi-perimeter, 24 inches over 2, or 12 inches. Means the area of that triangle is the square root of semi-perimeter times the semi-perimeter minus the first side, times the semi-perimeter minus the second side, times the semi-perimeter minus the third side. It's 27.71 square inches. Then we're going to subtract the 27.71 from the 33.49. Get a difference of 5.78, actually. Square inches, that's the segment. Look familiar? Let's have another circle here with center at O. Tangent that comes off like this. Another tangent that comes in. That's tangent at point A. And down here, this was tangent at point F. So this up here, the other end of that diameter will be point G. Point K here. Point J. That's what your points. I'm going to tell you that arc GE, 120 degrees. I'm going to tell you that angle ACF, 30 degrees. The length OG, what does that tell us? What is OG? That's OG. To the circle, that is radius, right? It's just telling us the radius of the circle. This upside down T is telling us that it's perpendicular, so OF is perpendicular to A. Now, look at that, OF, EJ. EJ is a chord, OF is a radius of the circle. If they're perpendicular, that's a right angle. Remember, that tells us that it also splits EJ, it splits the chord into two equal pieces. And if there was radii here, it would split that angle into two equal angles as well. And then we'll be told that EK equals 2. First question is find length GF. But really the trick on doing a problem like this is to be able to pick up just the information you need and be able to ignore everything else. GF is from here to here. It is simply the diameter of the circle. What's it have to be? 6 inches. Good. We know the radius is 3, so the diameter has to be 6. I'm going to label this over here. I gave you that ACF is 30 degrees. Next thing I'm going to ask you to find angle EDA. So let's come back here, find EDA. There's that angle right there. Well, I know that angle or arc PE around here is 120 degrees. That was given right here. The rest of this is going to be kind of tricky. I need to know the length of that arc there, don't I? But to know the length of that arc, I would have to know the degrees of that angle. The only way I could know the degrees of that angle is if I knew that angle. Now we're getting somewhere because that's something we can find. Draw in this shape right here in blue. What do I know about that shape? I got 30 degrees over here, but I also know that this is a right angle. That is a right angle because it's a radius to the point of tangency, or to a tangent line. Radius is always perpendicular to a tangent line. In a four-sided figure, how many degrees does the interior angles have to add up to? Remember, it's the number of sides minus 2 times 180. If it's 4 sides, that's 4 minus 2 times 180. How much does that come out to be? Four minus 2 is times 180. That whole figure has to come up 360 degrees. I've got 2 right angles, so I'm going to subtract 90 degrees twice. And I have the 30 degree angle. Subtract that, I am left with 150. Back up here, this has to be 150 degrees. Now, that's 150 degrees. What does that make this angle up here? 30. Very good. That makes this arc also 30 degrees. That makes this arc 120 plus 30, or 150. Now, this angle here is an inscribed angle. An inscribed angle is not equal to the arc, it is half the arc. Half of 150 is 25 degrees. For anything? Yeah, that's 75 degrees. Next thing I'm going to ask you to find angle EHF. Obviously in degrees. That there, put H right there. EHF, that angle right there. Find that, I'm looking at these two intersecting chords. I need to know this arc and that arc to find the angle between those intersecting chords. EF is easy to find. Why do I say it's easy? This is the diameter of the circle, which means this whole arc over here has to be half a circle or 180 degrees. This piece is 120, but 120 minus, or taken away from 180 leaves us with 60 degrees there. Next, we need to know probably this piece, huh? Right there. Yes, there, this one. You know, this arc over here is also 60 degrees because that's a chord that is perpendicular to radius, cuts the chord in half, but it also cuts the arc in half. So AJ is a total of 90 degrees. Oh, I know what we got. Very good. If I find this angle right here, I know that one, right? I have that angle there because I can look at this shape right here. Pull it out of there. That shape, I know I have angles here. This is 90 degrees, right angle, because that was the radius to the tangent. This was found to be 75 degrees right there, and this angle is 150 degrees. Four-sided figure, the sides add up to what again? So if I subtract there, what am I going to get? -70 minus 20 minus 75 is this angle here is 45 degrees. This one, 45 degrees. Next, I'm going to ask you to find the size of arc F in degrees. Arc ADF goes from here, there. Erased it here, but we already know that this is 30 degrees out here. ADF has to be 150, perfect. Subtract 30 off of the half circle, 180 degrees. Next, let's find FC. FC. Once you pick that one out, see if you can find the angle FC quick. It is 90, because OF is a radius, FC is a tangent, so it is just 90 degrees. What's the length KJ? Told you the EK is 2.5 inches. What's KJ have to be? All right, very good. Same length. Again, since the radius is perpendicular to the chord, it cuts it in half. What's the length EJ have to be? Careful. Add them together. There you go. 5.0 inches. And finally, ABD. ABD is right out here. This one's a little bit rough. Okay, it's a lot of bit rough. Angle ABD is a external angle, secant angle. It's found by taking this arc, which I know is 30 plus 120 or 100, minus this arc, which I've got to find yet, and then dividing by 2. Remember the difference of the arcs divided by 2? So we've got to find arc AD here. How do I find arc AD? Well, it comes down to this 45-degree angle here. That's a 45-degree angle. This is 60 degrees over here. I need to know this angle over here, figure out how things add up. Gotta go back and fix that angle yet, figure out what I did wrong here. So we need to know angle or arc AD, and we need to know angle EHF yet. Not 45 degrees, I screwed that one up. AD is not perpendicular. So I have to find that angle. I've got to go back out to this larger piece here. Hung up, I needed to know something. I know one, I know the other rather quickly. Oh, I didn't make this thing possible, so. Ever have one of those days where the little hamster just won't get on the wheel? We're having one of those days. Done this problem a few times before. I should know the answer pretty quickly. All else fails. Have still faith in your instructor when he has to look up the answer key.
Yeah.
Which one is that? EHF?
Mhm.
$80. Let's remember how it's 80 degrees. Oh, that's why I'm missing it. Helps if I can read my own writing. This arc here is actually given the 70-degree arc. That makes the problem a lot easier if I give you all the information. So to find this angle here, I'm going to erase this 80 degrees. Let's actually find it so we know where it came from. I'm looking at those two chords crossing again. I've got this arc down here that's 60 degrees. This one up here is 30 plus 70, which is 100. So since that intersects inside the circle, I add them together. Divided by 2. 60 plus 100 divided by 2. 160 divided by 2. For 80 degrees. That makes this 80 degrees. Now that that's 80 degrees, I can go out here and find B now. I could look in that bigger figure there, 360 degrees for a four-sided figure. But let's look at the angles. Arcs. Look at this arc, which is 150. Minus this small arc here, which was given to be 70. Divided by 2. So 150 minus 70 is 80. Divided by 2 makes that 40 degrees. Angle B out here, 40 degrees. ABD is 40. What do you think? Good stuff? I'm screwing up badly. I think that means it's time to cut her off for the day. There's a quiz out there. It is quiz 4-2. Dealing with the circles. Would you guys rather have a hard copy of it, or do you want us to get it out black one? A hard copy?
I'd like a hard copy, please.
Okay, you'll have to stop it and grab one. I'll be back on campus on Wednesday if you need to grab one. I'll get you guys one here before we go.
Actually, it's fine. I'll just print my own.
Okay. Homework. Big book. $682. Exercise 27-2. And page 686 through 688. Exercise 27-3. So a couple pages of homework to do. If you want to get started, I'll be online here to answer any questions for a while. And that quiz to do. One of the reasons we're cutting it a little short today is this is the end of Unit 2. Tomorrow is test. Now what we're going to do tomorrow, have that Unit 2 test or Unit 7 test, however you want to look at it. But also what I'm going to do is I'm going to take the whole class for the test. I normally wouldn't take a full 2-hour class for the test. I'd just give you an hour and then send you home to finish it. But there's a number of people missing quizzes. So we're going to take the full 2 hours tomorrow, work on the test. If you get it done, we're going to work on missing quizzes. We've reached the point in the course now that we're almost halfway through this semester, the second semester, where I start encouraging you to work with each other on the quizzes and tests. After this test, all of our tests and quizzes are gonna be basically a group effort. I'm not gonna like put you, because we're not allowed to let you sit around a table all together and work closely. I'm not gonna put you in groups to work on them, but you are more than welcome to work on them in groups. Consult with each other on your answers and stuff as you're working on. So that's what tomorrow's gonna be dedicated to. For those of you in the room here, I will get you hard copies of stuff.